ओके, हम ये कर सकते हैं, मीन्स आप रिकॉर्ड कर सकते हैं क्या? श्रीनिवास जी
Yeah.
ज्वाइन नहीं हो पाए बोल रहे थे,
Mm-hmm.
तो
Okay, so what we did in our last class?
we have done actually on this the class design.
That was object-oriented modeling. That is
Object
time
oriented
complexity.
modeling, that is,
Hmm.
yes,
That is time
time
complexity.
complexity we have done it,
So just get
yes.
a quick recap. So
Hmm.
time complexity in time complexity, what we did, we have just a minute, 2, 1. We did something like that. Mm, See,
Yeah.
we are actually doing the analysis of an algorithm. How we will
ओ
analyze an
करेक्ट
algorithm.
करेक्ट करेक्ट करेक्ट, ये
Okay.
क्लास मैंने कुछ नोट करके नहीं रखी हूँ कहीं पे, ये ढूंढ रही हूँ तो
So
नहीं
in the
मिल रहा
last
मेरे को।
class, what we did, we actually identified different types of algorithms. Okay.
हम्म,
After that, we try to
दिस
convert.
बिगो, करेक्ट करेक्ट।
After that, we try to convert. See, this is one kind of algo where you have
यस यस
where
करेक्ट,
you do not have any loop, any nested loop, any recursive function
नेस्टेड लूप,
call. That type of functions as algo can be represented as a mathematical function, and a mathematical
करेक्ट
function on
करेक्ट,
which mathematical function on the input size.
इनपुट
So
साइज,
input size is basically your n. Okay.
एन।
So this type of algo, this one, algo one. Okay. Are you able to see my desktop? I'm.
यस यस, इट इज शेयर्ड एंड वी कैन व्यू द स्क्रीन।
Can I annotate on this? Don't know. Actually, draw. Oh, okay. So no, I don't want to erase the thing. Anyway, still, see, control Z,
पेट्रोल सेड,
control Z नहीं काम करते शायद. Anyway, so this
हाँ
is the
विदाउट
type of
सेविंग,
algo.
ये बेस्ट आइडिया है,
Yeah, this is
विदाउट
this
सेविंग क्लोज
this
करना।
algo
हाँ,
basically do not contain any loop, any nested
यस
loop, any recursive function call. Okay,
करेक्ट,
so this type of algorithm are, we can say, can be represented by a function like that. Fn is equal to
एफ
c,
एन इज इक्वल टू,
where n is the size of the input, number of inputs. Okay,
करेक्ट,
size of the input, and c is the constant. Okay, so every function or algorithm can be represented mathematically by a function on the size of the input. Okay, the size of the input is represented here by n. So
एन,
this is basically a constant function because uh, we have taken into consideration that all the instructions
दिस आर
will
टेकिंग
be
टी टाइम,
at t time. Okay, so suppose this algo has 5 statements, so it will have 5t
5t,
time. Okay, 5t time. Now 5 is constant by itself, and t is also constant for a particular machine. Okay, because we have already
करेक्ट,
considered that for a particular machine we will consider each statement will be executed by a constant amount of time, and that is t.
यस
Okay, so hence 5t can be considered as a constant. Okay, so fn is equal
यस,
to c is a constant function. We say that this is a constant function. So
कांस्टेंट
all
फंक्शन,
the algorithms of this type which do not contain any loop, any nested loop, or any recursive function call, okay, can be considered as a constant function on n. Okay, so we did something like this in the last class. After that, we have another type of
रिकर्सिव,
algorithm. No, not recursive. We have another kind of algorithm where we have one loop, not nested loop, no
यस यस
recursion. It
वन
is a
लूप,
single loop, or you can have consecutive loops. Means you can have 2, 3, as many number of loops you may want. You can have multiple loops. That type of algorithm can be represented mathematically by this type of function, that is a linear function on n. Okay, that is a linear function on n.
लीनियर फंक्शन ऑन,
We have already covered how to calculate this, how we get fn is equal to an plus b in our last video. Okay, you can also watch that thing. So
Yes,
an algorithm or a function which contains a single loop. Single loop means no nested loop, okay, and no
yes.
recursive function call can be represented using this function,
This one,
this type of mathematical function,
linear
linear,
function.
linear function on n. Okay.
Hmm.
Now, next you have something, this type of algorithm, algo 3, where you have nested loops.
Nested loop. Hmm.
Okay, here you have nested loop, still no recursive function call, you have only nested loop, and nested loop in such a way that it will iterate, means
It's
number
means
of n
number of
times,
inner yes, n number of
n
times.
times. Okay, so these loops are not like that. See, the inner loop is dependent on the outer loop, it's not like that.
Outer loop.
Okay, it's independent loop, two independent
Yes.
loops are running together, okay, which depends on the
Hmm.
value of n. Okay, so this
Hmm.
type of nested loop, if your algorithm contains this type of nested loop, okay, so
Hmm.
nested loop means two level, one and two level. Okay.
One outer level and outer loop, and one more the inner loop.
Two level, then just, so if your algorithm contains this type of loop, then this algorithm can be represented using this function on n, that is a quadratic function. Okay, n
A
square plus
quadratic
bn.
function n square plus bn
Yeah,
plus c.
again, how we derive that function from this algorithm, we have done it in the last class. Okay,
Yes.
so now the, okay, so up to this we did. Okay,
Hmm.
now we will do something, that how a, okay, up to this we did. Okay, so we will consider now something called asymptotic notations, okay,
Yeah, we
to represent.
remember. We are
Okay,
talking
let's move,
about this. Hmm.
let's try to understand. Now, what is an asymptote? I told you last class, asymptotes, asymptotic notations. So basically there are three notations, asymptotic notations. One is pronounced as big O,
Yes.
big O. Another is your big omega,
Big omega
and another is your big theta or theta,
theta.
theta. So the symbol of big omega is something like that, and theta
Mm.
is something like that. Okay,
Mm.
so these are the three symbols used for asymptotic notations. Now, what is asymptotic notation? Why we need that thing?
Mm.
Now, see, we have to understand something. Suppose this is your time, okay,
Mm.
and this is your number of input, size of input n.
Input, size of input n.
So, if we plot
Mm.
the time taken by an
Graph.
algorithm, okay,
Mm.
against the number of input or the size, okay,
Mm.
then we can get a graph, na? Then we can get a graph. Say for example, I told you that, take example for say bubble shot. You remember that name, bubble shot?
Yes, I remember. I remember we had written this. are also varying from.
Bubble sort, or you may say
Yes.
binary search or search, any
Mm,
search, linear search, you say linear search for simplicity, search linear. Okay, so
mm,
these are the algorithms. Okay, now suppose I say
mm,
that to sort, mm,
mm,
or I am taking this search algorithm. Say I have
mm.
mm, one element,
Yeah, one element to be searched, we start
one element to be
comparing with
searched.
all the elements.
No, no, no. We have
Mm.
the suppose how we search. We will have an array.
First, it should be indexed. It should be a sorted. It should be in sorted array.
No, no,
We'll
no.
take an
We are not
element
considering.
and
We are not considering about the binary search. Okay, it's a linear search. Simple. So what we have? We will
huh,
have a list, an array. Okay. Inside that array, we
yes,
will have some numbers. Okay.
yes. We
Say suppose
start
numbers
comparing
is,
with.
say number like that 5, 7,
Mm,
minus 1.
mm,
Okay, 2. Again 5 is there. Again 2 is there. Something like that. We will have some
mm,
numbers like that, and we are going to search some numbers, say k,
mm,
in the array. Okay. Now I
mm.
am telling you, see what is the size of input here. This is the size of input.
The
You have
size of
one,
time.
2, 3, 4,
6.
5, 6. So you have 6. I am saying that suppose you have just one element in the array,
Mm.
and within the one element you have to search an element whether it is found or not. So I can say
Oh.
n will be 1 here. Okay,
Mm.
so what time it will take? It will take maybe, if I call it a 1 unit
T
of time,
time. Mm.
1 unit of time.
1 T.
Okay,
Mm.
maybe say if I say that you have two elements in the array,
Then
among the
2
two
T time.
elements you have to search a particular element, say some amount of time
Mm.
here. So I can plot like that, I can plot like that. Okay, in that
Mm.
way I am saying that you have 10 elements in the array. Okay, say 10
Mm.
elements in the array, something like that, 10 elements. So
Mm.
among the 10 elements you have to find the value, you have to search k if it is present or not. So you will take some
Mm.
time, maybe this is the time, maybe this is the time.
Mm.
Okay, in between you have some other times also. Are you getting the thing?
Mm.
Now suppose I
Yes.
am saying that you have 100 elements in the array, 100 elements. Okay,
Mm.
so within the 100 elements if I plot like that, so maybe we will get some, this point, this time is taken to search a particular
Mm.
value from 100 elements.
Mm.
So what you are getting?
Mm.
You are getting a graph,
Further graph.
a graph. Okay,
Mm.
is it clear? So
Mm.
searching, if I plot the time taken by the algorithm to search the element
Versus the
among the
number of
array,
lines.
so you will
Mm.
get a graph. Eventually you will get a
Mm.
graph, right? Now see,
Mm.
the length of the graph, means the height of the graph, is important, huh? So this tell
Mm.
you the time.
Mm.
This is telling you the time,
Yes.
how much time it is taking for
Yes.
a particular size. Okay,
Searching.
right. Okay,
Yes.
so suppose I am taking, this is for linear search. Now I am considering, say I will consider a search, binary search. Okay,
Mm.
and we all know that binary search is more efficient than linear search. Huh? We know that.
Yes.
Why, that we will discuss. So binary search is more efficient than linear search. So in the binary search, maybe this array need to be sorted. Okay, no problem, we sorted array. And if we plot the binary search, maybe we will find that our
With
graph
less time comparatively. Mm.
look like something. Maybe,
Mm.
maybe. I'm just assuming. Okay. So
Mm.
here is the point of consideration. See,
Mm.
this is the time taken by the
Mm.
linear search to find k element. and this is the time taken by the binary search to find the k element from the array of same n size, so same n value. This is the time taken by the linear search to find the k. Say it is k1, it is
complexity.
k2, okay, for the value of n2, something like that. Are you getting the thing? So I am making you understand that you can plot a graph. Okay, if
We
you
can
get the
analyze the
time,
time
yeah,
easily.
if you
Yes,
calculate the
can.
time, running time, then you can plot a graph. But we generally do not need the running time. It's it's not mandatory, or it's not useful to take a stopwatch and watch how many times it is taking to find a particular element in an array. There is no need of that thing, because what our purpose is that we have two algorithms. One is your linear search, another is your binary search. So we have to compare the two search, which one is better for which type of input. Okay, if we found by some means, if we found that linear search is better, if somebody tells me that linear search is better than binary search for this type of inputs, then it is okay. If I found that binary search is better than linear search for some inputs, then it is also okay. So it is not, what I am trying to say, it is not necessary to find you the exact running time taken by the two algorithms, different algorithms. You do not need the exact running time. Okay, we need a comparison. We need a comparison. We have to compare between among different algorithms, which one is our best algorithm for a certain input size. Okay, that is our motto. Okay, now how to compare these two? How to compare these algorithms? The time. Okay, for that purpose, we already represented each and every uh, uh, algorithms and functions to its respective mathematical notations, respective mathematical functions. Okay, uh, we need some notations to represent the time taken by, okay, a particular algorithm, and that representation can be done by asymptotic notations. Okay,
Okay.
asymptotic notations. So what is asymptotic notation? Asymptotic notations are basically some symbols, symbolic representation, which will reflect the time
The
taken by a
time
particular
taken by the
algorithm
algorithm for n number of inputs.
for a number of inputs. Okay, so it is not exact time, it is not exactly running time. You cannot say
Exact
that
time.
this much millisecond, this much hour. Okay, we do not need that at all. It's a symbolic representation. Okay, okay, fine. Now see, in this graph, I'm again taking and drawing another graph. We need to understand these things, and these are not very complex at all. See, suppose there is an
Time.
algorithm, and that algorithm is looking like that. If we plot that algorithm against t and
By
n,
n versus n.
okay, so we are getting this graph. Okay, now if someone can tell me that see, this is our fn. Okay, say we have our algorithm, just a minute, we have our algorithm a1, a1 algorithm. Okay, and this a1 algorithm is function of n, fn, let's consider. Okay, now we are trying to find out, we are trying to analyze this a1 algorithm. So if I plot this fn in this graph, okay, and if somehow I can bound this thing, I can bound this graph, means I can tell that this is the maximum limit fn can go,
Take it.
and this is the minimum
Go.
limit Fn can be less. Okay. So these are called
Can
bounds.
specify the range.
Okay.
Okay.
And we are interested in the bounds only. See, when you are buying a machine, suppose you are going to buy a car. Okay. So on what you are interested apart from its price? See, maybe
Mileage.
mileage. Okay. So what is the maximum amount of petrol or
It
the
will
fuel it
consume
will consume to run 1 kilometer? Okay.
1 kilometer.
Or what is the minimum amount of petrol is needed? So that is your target. Okay.
Yes.
You can do it in reverse order in some other comparison also. Say what is the maximum speed it can go and
It
what is the
can go
minimum speed it
in
can go,
1 liter of petrol or some
right?
unit of fuel.
So these are the bounds we looking for when we are going to purchase a machine. Now here there are two interesting things. Okay, see what I said to you. If I say mileage, just imagine mileage. Mileage means what? With 1 liter of petrol,
The
1 liter of
petrol, how many kilometers it will travel?
how many kilometers it will go, right?
Yes.
There will be a maximum and there will be a minimum.
There will be minimum.
There will be a maximum, there will be a minimum, right?
Yes.
Just think deeply to calculate the mileage or to compare the mileage. Mileage means what? With 1 liter of fuel, how far it can go or how less it can go, means the maximum amount of kilometer it can travel with 1 liter of petrol and the minimum amount of kilometer it can travel with 1 liter
Kilometer
of
can
petrol.
travel with 1 liter.
Okay, now see, if I consider the speed, then what will happen? So for this for this you will have a maximum limit, right? This will be your max.
Yes.
I said that with 1 liter of petrol you maximum can go 30 kilometers. The minimum, after you are not doing service properly or maybe some other reasons, minimum
It
you
may
will go
reduce. It may come to.
10 kilometers, right?
Yes.
This can happen. This is minimum.
Yes.
So you will
Yes.
have two bounds. This is called your upper bound
And lower bound.
upper bound and this is your lower bound. Okay, if you want to understand how to analyze an algorithm, you have to understand my words, what I am trying to say in this video, okay,
Yes,
or in this class. Okay,
I can
so
understand this.
yeah,
Upper bound and lower bound.
upper bound and lower bound. Now there are some other cases. See, suppose if we consider speed, then tell me, we need only maximum speed, na? Do we really need any minimum speed? Because minimum to
No,
will be
generally we
0.
will not take. Yes.
We do not
Generally
require
we
the
will not
minimum speed.
concentrate.
We require only the maximum speed. Okay. So in that case, if we can have graph something like that. Now, because the limit we know that this is 0. This is 0. This
Yes.
is 0, na? This is 0.
Yes. Minimum
Because
is lower bound is 0.
lower bound is always 0. We do not require the lower bound at
We
all.
require the
In that case, what we require only is the upper bound.
upper.
So we fixed that only upper bound is required. Very important topic. We require in this case only the upper bound. Okay. And there are some cases. Okay. if you can give some example, in some cases we do not require the upper bound, we just require the lower bound, because in that cases the graph will show
Not
something
going to a
like that.
negative value.
Okay,
Okay.
so we do not require the
Mm.
upper bound in that
Upper
cases,
bar.
because upper bound will always be fixed.
Graph.
It will
Yes.
not go beyond that thing.
Increase.
Okay.
Yes. It will. Mm.
So here you will have the lower bound. You require the lower bound only, right?
Mm. Mm.
Can you give me some example of that type of thing?
That's what I'm like. Uh,
Lower bound. Suppose,
Temperature
can you?
will vary.
Huh?
Suppose if we are taking temperature, sometimes it may go in increasing order also. What
Sorry, I am
could
not
be
able
in
to
the
understand because your voice is cracking.
the voice? Because of problem with the internet here, too
Trouble
much
with
of
internet.
disturbance is there.
Okay, no problem. You are able to hear my voice, huh?
Yes, I can hear you.
Yeah, yeah. Okay.
I was
See,
telling thinking of temperature, but temperature will not be considered. We cannot consider temperature here, I think, because it can go in any
still I am
way.
not
I
properly
was saying.
understanding. Okay, I am giving you a
Okay, fine.
example, very simple example.
Uh,
Suppose
uh,
the, I hope you all visit to market. Okay, suppose the price
is
of price. Recently in
uh,
West Bengal, price of potato. Okay, is
uh,
we Bengali log usually take potatoes heavily. Okay, in
yes, yes,
every dishes we have
everything.
potatoes. So price
Yes,
of
yes.
potato. Okay,
Uh,
price of potato. You know that it will never reach to zero, na?
yes,
Price of potato can never reach to zero. But
yeah.
currently, maximum price of potato here is your 50 rupees 50.
Mm,
That is fixed. Okay, government makes a
mm,
maximum limit fixed.
mm,
Rupees
yes.
50 is the maximum price of potato in the market. Okay. Now some uh, sabji seller is giving discount. Some uh, your maybe Reliance is giving 20% discount, something like that. So it can reaches to, it has a lower bound, but the upper bound is fixed max. We do not require the upper bound. What we require? We require the lower bound. Are you getting the things? We require the lower bound here. So this is the
Yes.
case for this thing, lower bound. We require the upper bound for here, and we in some cases we require upper bound and lower bound. Now tell me, among these three items, which one is most common and which one is less common, very less common? Can you identify?
Hmm. Upper upper bound can be common.
Yeah, upper bound can be common. I can say that this is the most common, means in most of the cases we will have an upper bound, we will have a lower bound. Okay,
Yes.
and between that our graph will go. In most of the
Yes.
cases we will have some upper bound and we will have also have some lower bound.
No.
Okay,
Yes.
and in a very least case we will have the lower bound only.
Lower
Okay,
bound. Yes.
but what is most necessary is this one, upper bound.
Hmm.
Okay, this is the most necessary thing,
Hmm.
because we always interest to know what is the worst amount of time
Hmm.
taken by an algorithm in the worst case scenario, means what is the maximum amount of time taken by an algorithm to produce the output. That is our
Yes.
interest. That is our interest. Okay,
Hmm.
as a client, if I found your algorithm is taking, I have a limitation, no? I have a
Mm.
limit.
Yes, I can
Okay.
take it. Mm.
Okay. So if your algorithm takes a
Mm.
time beyond that, so I will reject your algorithm.
Yes.
But if your algorithm has a time
Mm.
within the limit, within my limit, so I will take your algorithm. So in
Definitely.
most cases, we are interested in this
Upper bound.
upper bound only. Okay. And the thing is, finally, come to conclusion that I am telling you that this is represented by big O, upper bound.
Big O is upper
Big O.
bound. Okay.
This is
Mm.
represented by theta,
Mm.
both upper bound and lower bound. Okay.
Mm.
And this is represented by omega.
Omega.
So again, for an algorithm, if we found some upper bound and lower bound at the
Both
same time,
upper bound and lower
so
bound,
it is
that
the
will be
theta,
measured in
theta.
theta.
Okay,
Only upper bound or big O.
big O,
Lower bound is omega.
omega. And in your algorithm analysis subject, you
Mm.
will find big O most of the time, because we are very much interested about the maximum amount of time taken by an
Maximum.
algorithm. And
And
sometimes we
yeah,
are also interested of taking theta,
minimum lower
because
bound.
upper bound and lower bound are both considered in theta. Okay, but we
Mm.
very rarely need this omega.
Other two.
Okay,
Mm.
that's why big O is most important. Okay,
Mm.
it will give you the maximum amount of time that will be taken by an algorithm to execute.
Mm.
So you understand the characteristics of the curve now.
Yes.
Theta curve will look like this. Omega, sorry, O curve will
Big O
something
car. Mm.
like that. Why I am saying like that? And that for this curve we need only big O, because we do not need the lower bound. Okay, and for lower bound, but for omega curve maybe like that. Okay, so
Mm.
up to this I hope clear na
Yes, it is
somehow.
clear.
Okay,
Mm.
now the next part, how to calculate.
Am I
There,
audible now properly?
yeah, exactly right. You are audible now. Sorry. Okay, now we will discuss three lemma. Okay, three theorems. A small theorem, very small theorem, for those big omega, big theta, and everything. So first we consider the big O, big O part. So it is big O. Let f of n is a function, and if there exist two positive constants c and n0, say I will write n0 in suffix,
Mm.
and we get another function g of n such that say here I have to write n0.
Mm.
let fn is a function, okay, and if there exists two positive constants c and n0, and we get another function gn such that f of n less than equal to c multiplied by g of n, where for all this is a symbol of for all, you all know this is a
Yes, in
symbol
the
of for
math.
all. Yeah, for all n greater than equal to n0.
One.
N0. Okay, then we can say f of f of n is equal to big O of g of n. F of n is equal to big O of g of n. So this is the theorem for big O. Okay. Now what is it? If there is a function fn, okay, don't think that this is a very deep mathematics, and do not forget about all those things. Okay, fn, gn, cn, no, you do not have to think like that. Okay, just imagine that fn is a function, okay, and we somehow we find two positive constants c and n0, and we get another function on on n, that is gn, such that this what do you say, this inequality, okay, this condition, you can say this is a condition, okay, this condition satisfy for all values of this, then we can say fn is equal to big O of gn. I am giving you an example that will be more helpful for you. Suppose fn, my mouse sometimes get freeze. See, this is a new laptop, but already the USB port get loose. Okay, so suppose huh?
The one.
Again your voice is cracking.
Today lots of disturbance in the internet. Connection is not stable.
Yeah, connection is not stable. It happens. Especially if you are connecting through mobile network, then it is more vulnerable for a long discussion. Anyway, say this is a function, okay. Suppose this is a function fn is equal to 3n plus 2, okay. This fn, I am saying that this fn is equal to 3n plus 2, okay. Now for this fn we have to find out the big O. How to find? Now by inspection we say that gn, we are considering that gn is equal to take n. You always consider, because see here fn is less than equal to c into gn, na? C into gn. Now if you remember the big O graph,
Yes.
so how it was there, see here,
It is in a waveform.
so this is your, maybe this is your fn, okay, this is your fn. Now you have to find a gn, means there is another graph, this will be your gn, okay, and that gn will always be greater than the difference. This difference is your c, this c.
Yes.
Okay, so you have to find a gn, okay, which is greater than, because gn will be the upper bound of fn. We say that gn will be the upper bound of fn. So you have to fix up the gn with some value. Okay. Now what will be the value? We can say that take
Anything greater than n of n0.
what will be your C and what will be the your NG
N.
here to satisfy this condition, so that 3n plus 2
Mm.
will be less than equal to C into
C
means
into
C
G of
into Gn. We are taking
G
Gn as n.
n and this
Okay.
2.
So what can be the value? What will be the value of C and n? Can you tell me?
C and n.
See, if I put C is equal to 4, okay,
Mm.
and n0 is 2, okay,
Mm.
how can I decide these values? You can decide the value by some mathematical calculation, but do not go with that mathematical calculation. You just put values something like that. Say if you put C equal to 1, I'm just making a rough. C equal to 1 and n is equal to 1. So 1 into 1 means what? 1 into 1
1
means
only
1.
will.
So what will be there? In the left hand
It is
side, it will
not
be
less than.
3
Yes.
into 1 plus 2 means 5
Will
less
become
than
more.
equal to 1. So that is not possible. Okay. So if
Because
you
always G
consider,
of n should be more.
yeah, if you consider n as 1, then what will be the minimum value here? So it will be 5.
1 only.
So it must be always less than equal to 5. Okay. So you can consider C as 5. You can consider C
And
as 5 also.
mm.
So if you consider C as 5, then n0 will
Mm.
be your 1. Okay. You can take any value. You
Mm.
can take any value. Okay. So
Mm.
if I take C is equal to 5 and n0 is equal to 1, okay, then try
Mm.
to satisfy, check whether these values satisfy this condition. Suppose I am taking C is equal to 5 and n0 equal to 1. So if n0 equal to 1,
It is equal to
so it will be for the
5
value of
equal to 5.
5, it is satisfied. For the value of n equal to 2, what will happen? So it will be 5 into 2 means 10. Huh?
2 will
It
be
will be
10.
10. So what it will be?
Mm.
3
This
into
value
2
will be
means
less than
6 and 8.
6
So
plus
it is
2
true.
8.
It is true also.
Mm.
For the value n is equal to 3, what will happen? It will be 15, and this
For
will be
that
your.
also it is certain. It is
So for
3,
all
3 is a 9,
values,
11.
it will be true.
Mm.
Okay, and it will be same for n C is equal to 4 and 2 also, right?
Mm.
So we can say that we have found, keeping in mind of fn is equal to 3n plus 2, we have found, we have successfully found that gn is equal to n, and if we take the value of c and n0 as 4 2 or 5 1, then this condition satisfied. Means there are
Mm.
some values of c and n0 for which this condition satisfy, right? For
Mm.
any value of c and n0, if this condition satisfy, we say that fn gn is the, I am repeating,
Mm.
if we find
Big
any
go.
value of c and n0 for which this condition satisfy, okay, we can say that
Mm.
fn is equal to big O of gn. If we
Mm.
can say, if we can find that fn is equal to big O of gn,
G n, G of n.
then we say
Mm.
that g of n is the upper bound of f of n. Okay, then we say that gn is the upper bound of fn. Are you getting the
Mm.
things?
Yes.
Okay, so if our function is fn is equal to 3n plus 2, then what will be our gn?
Mm.
Our gn will be,
Be C into.
gn is the upper bound of fn though. Then
Yes.
here you say, I am just typing, So what was our function? 3n plus 2. Okay. So 3n plus 2 can be written as big O of Gn. Na? Now what is Gn?
G. Gn is C into N.
No,
N,
Gn is your
N,
n. Gn is your n.
N. Okay, it is greater than f of n.
Yeah. What is Gn? Gn is your n. Na?
Yes.
So 3n plus 2, if your function is 3n plus 2, then its equivalent big O notation is big O of n.
Okay.
Is it okay?
Mm.
It is same. Here it is same. That n is the upper bound. You can say the upper bound of this function. We can say the big O of n is the upper bound of 3n plus 2.
Mm.
Okay.
Here less than will not come. It will come equal to. Okay.
Sorry.
The less than will not come here. 3n plus 2 is equal to big O only will come. Because we
Yeah.
saw the values here less than and equal to both.
Yeah, you consider this definition. If fn is a function, okay, this one,
Uh,
and if there
uh,
exists two positive constants c and n0, we found two positive
mm,
constants c and n0. With that, we also found another function g of n. This is a g of n,
mm,
such that this condition satisfies. So for all these values, this condition satisfy. Then we can say fn is equal to big O of gn.
okay.
Okay.
We are
So
arriving to the final step.
yeah. So since we found all those values, okay, so we can say
Mm,
fn means your 3n plus 2 is equal to big O of n. Okay,
mm,
means this
mm,
is the upper bound of your this function fn. Okay,
mm,
now see another example. Just you clear one thing, then the other things will also be cleared. Suppose there is another function, maybe you can check like that.
mm,
Say fn, sorry, fn is equal to, say, I can give you that 10.
mm,
No, I have to write like that. Say maybe 10 n square, okay,
mm,
plus
mm.
2n plus, say, 1. Say suppose a function is like that. Okay,
Quadratic. Mm.
quadratic function.
For linear quadratic function, if it is there.
For this function, we also need to find a perfect gn, a c, and a
Mm.
n0.
Yes, not zero.
Can you
Mm.
guess what will be the gn value and what will be the c and what will be your n0?
It will be n square. Gn will be n
Yeah,
square.
it will be n square, exactly, because you have to consider the
Highest range. Upper
highest
bound
power,
we need to consider here.
because we are finding the upper bound. Okay,
Yes.
so what will be your c and what will be your n0? I hope you can find out what will be the value of c
C
and
will be
n0.
1. C will be
C,
1.
okay, say
And
10,
yes.
10n square plus 2n plus 1 less than equal to, you have to find n square. Okay, n square, you have to
Mm.
put some value of c so that it satisfy less than
This
equal to.
satisfies.
Okay,
Mm.
if you put c is equal to 1, then n square, say if you put n equal to 1, then what will be the value of this thing? So 10 plus 2
10
plus
plus
1 means
plus
13.
1. 13.
Okay, so the best way to
Mm.
get rid of the thing that you put c is equal to 13. So 13
Mm.
into 1 is less than equal to 13. Na?
Mm.
So in that way you can find out. There is no means
Okay.
no complex theme. It is not very complex theme to find a c and n0 so that this condition satisfied. So you will
Okay.
eventually get all these values. Now since you get
Mm.
all these values, that means for this function, okay, you are and I must tell you that there are some functions for which you will not able to get these values at all. Okay, so for that functions you will not get the upper bound. Okay, so but for this function you will obviously get an upper bound, and what you can say that for this function you can represent the big O notation as what? Big O of
G
g of n.
N
Yeah,
N
g of n is your n square, na? So you
N
can write
square.
big O of n square. Okay, so what type of function this is? This fn is equal to 3n plus 2. If you remember that our
Looping.
this one, if you remember that, see, fn is equal to an plus b, linear function, na? So this type of algorithm,
Yes.
algo 2 type 2, this type of algorithm can be represented using this mathematical function, and this mathematical function big O representation will be your big O of n. Why we wrote this big O of n last day, you are get clear here. Say fn is equal to, if it is fn is equal to say an plus b, if your function is like that, then it is respective big O notation will be big O of n. Are you getting the thing?
Please come again with this.
Sorry.
The last one. Can you please come again with the last point again?
Yeah. See here, last day we did this thing. Now, this is the type of algorithm where you have only one loop, no nested loop, no recursive
One.
function. So
Yes.
this
In
function
this
was
function we
represented
got this.
as fn
Linear
is equal
function.
to an plus b. Okay.
Mm.
Now here see the function fn is equal to 3n plus 2. This is same thing, na? An plus b. This is something like an plus
Correct.
b.
Yes. And
So I
correct.
told you in the
So
last
we
class,
defined it is. Yes,
if
it is
your
big
if you
O.
if your function is b, fn is equal to n plus b,
Mm.
so it will be represented in time complexity as big O of n. So how? Why?
Yes.
Because of this.
We got
Okay.
this great. Okay.
Now if your function is,
Okay. Got it.
if your function is quadratic, see, if your function is quadratic, an square plus bn plus c, so it will be represented in big O notation as big O of n square.
Big of notation of n
How?
square.
Because of this. See,
We approved it
an
today.
square plus bn plus c, so it will be represented as big O of n square. Okay. So in this way, n cube, big O of n cube, n to the power 4, maybe something like that. So big O representation, we represent the algorithms uh,
By considering the upper end
by considering, by
bound.
telling
Sorry.
the big O notation, we are actually telling you the upper bound of the algorithm. Okay, and this is
Yes.
the respective graph. Okay, so this is your t and this is
And
your
VTN.
n. Okay, so this is your big O notation. Okay.
Okay.
Okay. Now one thing you can tell me.
Last year in the quiz we understood now.
uh, your side network today is very much disturbing. That's why I am not able to understand you by any means.
Oh, sorry. Really sorry. I'm unable. Unfortunately, it does not have the other connection also today.
I know. Okay, see one thing
That is very.
that through asymptotic notation big O, how using this lemma or this theorem, how we derive
Mm.
this big O from this 10n square plus 2n plus 1, how we derive this big O of n
Yes.
square, we understand. Okay, but one more
Yes. Yes.
analysis I can put here. See, that is called rate of growth. Okay,
Mm-hmm.
which is called rate of growth.
Rate of growth.
That is another very much important term, rate of growth. Okay. Now, what is rate of growth? Rate of growth is something which is the most essential and crucial part in analysis of algorithm.
All the time.
Now, rate of growth means what? Suppose this is the value. Okay, this is the value of the time take. Okay,
Fine.
consider this is the function, this is the value of time. Now we have to find out the value of fn, okay, with respect to the value of n. Okay, now for value of, say, value of n equal to 1, so it will be your 13, right?
Yes.
Okay, no, I am giving you in some direction. See, fn has 3 components, 1, 2 and 3, right? So depending on the value of n, what will be the contribution of these 3 individual values? Say 10, n square,
2n, 1.
and 1. Okay. So depending on the value of n, what will be the contribution of these individual terms in fn? So n will be your, if your n is 1, so it will be your 10.
10,
It will be
10,
your
2,
2. It will be your
1.
1. If your value of 2, then what will be the value of this thing?
20.
2 to the power 4.
2 to 40.
2 to the power 2
40.
means 40.
40.
And
Then
it is your 4.
it is 4.
It is your 1.
It is
Okay.
2.
No, it is 1. It is always 1. Plus 1 though.
Okay, fine.
So if it is 3, so it is your 90.
90.
Okay. It is
This
your
will
6.
be.
This is again 1.
This is 1.
So in this way, you can guess if it is 10, so it will be 1,000. Nah, it will be your 20 only.
Yes.
It will be your 1, right? So now if you continue increasing the value of n, tell me which part is contributing the most in this fn? Clearly this 10n
N
square.
square.
So
N square.
for higher values of n, the contribution in the total time of these two terms are very, very negligible. So we do not, because we are comparing, okay, approximately, okay, we are not getting the exact running time. So for the higher values of n, the contribution of these terms are very much negligible. Okay.
Yes.
So we consider only this term. So what is our term? Say n is your, with respect to 10 n square, right? Now in this 10 n square, again the contribution of 10 is constant, right?
Yes.
So we can only consider the
N square.
term n square. So if we only consider the term n square, so we can put it inside the big O notation n square.
Big notation.
So here what we have done, we are considering the rate of growth, means
Based on N
for
square.
the higher values of n, not for the lower values of n we are interested. We are especially interested when the
Only the
input
upper
size
bound
is
values of
really
N.
big. Okay, say hundreds and thousands and millions of input size it is taking the algorithm, then how our algorithm is going to perform, that is our matter of interest. Okay. So that is called rate of growth. So when we are considering multiple algorithms, so maybe multiple algorithms like that, they are producing the graphs. Okay, they are producing the graph. Okay, I'm just making it clear. So suppose for a particular problem, okay, you have a graph like that. Okay, you have a graph like that.
Okay.
So this is your f1n. That is one algorithm. Okay, you have a problem, and for that problem you have been proposed with 3 algorithms, right? Among the 3
Okay.
algorithms, first algorithm is, if you plot the first algorithm, it will give you this graph. Okay, for the next algorithm you are getting this graph. Okay, so F2 and for the third algorithm you are getting this one, say F3. Now tell me which one is most means which algorithm we will accept. The algorithm, this one, the F3 will be accepted, because see here F1, see when the value of n is small, F1 is something like that, okay, but if when the value of n is gradually increased, it is growing up. So rate of growth is Fn.
Growth rate is higher.
The rate of growth of Fn is much greater than F2, and which okay,
been increased.
much greater than F3. So clearly the rate of growth of F3 is, for higher values of n, is much acceptable to us. So we will choose the algorithm F3, even if for the lower values of n it is taking more amount of time. See, for the lower values of n it is taking more amount of time na? But after a certain point of size increase, for real big size of n, see here n is really big, okay, so for more data, for more number of input size, this will produce you the efficient output in a very less amount of time.
Here
So we will consider.
I got hello.
Yes.
Am I audible or still?
You are audible, but your voice is breaking sometimes.
Okay. Actually, I had a doubt here, because when the graph is coming decreasing way, we found in lower bound which was not that efficient, right?
No.
When we are representing
I don't know if I can understand you properly, because your voice is cracking. Since, see here, as you increase the number of size, okay, your time is decreasing, na? Your time is decreasing for this graph. Means for a huge number of input, you are producing the output in a less amount of time than this algo, than this algo. So that's why we are interested in this algo. We accept this algo. Are you getting the thing?
Okay.
Suppose for a
check with
certain,
this later, because I think I'm not able to confirm what exactly I wanted to ask.
yeah, you can write in chat box also if you think.
Okay.
Just check it once.
I'm using my mobile also, so the problem is this also.
Are you writing something?
I thought of writing.
Okay.
Like I'm not exactly getting like.
Here you have some confusion.
Yes, I have some confusion. With omega, I have confusion that we represented
Omega.
omega.
Okay, we did
There
not.
in omega, we actually did go with that kind of thing. Here with related to.
We are not discussed omega at all. Okay, we have discussed only big O today.
Okay,
That big O and big theta are not considered here. Okay, so don't mix up this
No,
thing.
I got it.
We just
Yes, I
we
was mixing up. That's the reason
oh
I was having a.
no.
Sorry, okay.
We just discuss the big O. We the give you the theorem of big
Got
O
it
only.
clear, but the concept I was mixing, like I was interlinking in a wrong way.
It is completely about big O.
Interrelating
Okay.
them. Yes.
We
I
did
was
not men
wrongly interrelating the
yeah,
two.
yeah.
That is completely omega is different and we are purely discussing what go.
Yeah, yeah.
Variations in big O.
Mm.
Okay, got it.
We
My
have
doubt
only
is clear.
discussed big O today. Okay,
Mhm.
we do not discuss about the theta. I just give you a short description or short thought. What is theta? Where theta is applied? Where big O is applied? Where omega is
No, why
applied? That I have
I
told you
was
here.
wrongly mm-hmm. No. The problem was I was wrongly correlating with only keeping the graph in mind.
Okay.
That is the
Okay,
reason I
so
got confused. I
rate
got
of
it now.
growth, rate of growth
Mm.
for we are
We
representing
go.
it with big O. Okay. So in this way, we have to analyze the algorithms and choose our best algorithm, which is our most efficient algorithm. And we can have a scale. We have a scale something like that. Say
Mm-hmm.
obviously big O of just something like that. Big O of 1 is the most efficient algorithm because it takes the constant time. But obviously, not all
Okay.
algorithm can produce the output in constant time. Okay. After that, big O of log n.
Mm.
Big O of log n is the next best time. Okay. Next,
Mm-hmm.
you will have big O of n, linear time. Okay. Next, you
Mm-hmm.
will have big O of n log n. Now, how
Mm-hmm.
this log n appears, that I will also discuss in respective next consecutive classes. Okay. So big O of n log n. Next, we will have
Mm-hmm.
something big O of n square,
Mm-hmm.
big O of n cube. Okay. And
Okay.
you have
So on
exponential
like that.
time big O of say 2 to the power n. Okay.
Mm.
And big O of factorial n factorial. Okay. These are
Okay.
really big amount of time. Okay. So this is basically scale.
Mm-hmm.
Now suppose you have algorithm A1, okay, for a particular solution, for a particular problem, you have been proposed with three algorithms, A1, A2, and A3.
Mm-hmm.
Okay. Now after analyzing the say three companies
All.
provide you the three algorithms for solution
Mm.
as a solution. Okay.
Mm.
Now this
Okay.
company is claiming that my algorithm is taking this amount of time. Okay. Or
Oh
my
my. Oh,
algorithm's rate
big
of
go of
growth is
N.
this one. This
Mm.
company is telling my algorithm's rate of growth or time is this one, and this is saying
Mm.
mine is of this one. Then which one you will take? You will take
O log O. Big O log N.
this one, big O of log n,
Mm.
because this is the
Mm.
least rate
Least.
of growth, showing least
Mm.
rate of growth. Okay, means for the higher values of n, this algorithm, if I consider for the higher values of n, this algorithm will give me the output in the less
Okay.
amount of time, minimum amount of
Very
time.
less. Short amount of.
Okay.
Mm.
So this is the case you have to consider, and we done this big O notation. This is called asymptotic notation. Okay. Asymptotes basically subject or a curve in mathematics. The curves said that two curves are called asymptotes if they are reaching to each other but never meet. Okay, those two curves, those
Yes,
types of curves
I
are called
remember.
asymptotes. Okay, they
Mm.
will never meet, but they are 10 means they are reaching to each other. Okay, but will never meet. These two types of curve are called asymptotes. So here, if I say that these two, this curve and these curves are two asymptotes, means what? Means
Mm.
they will never
They will
meet with
never
each
meet
other in the future. Okay,
future. Mm.
okay. So that's why we are getting this term asymptotic notation. Okay.
Okay.
So this is all about big O notations, how to consider the asymptotic notations here. And
Mm.
another two asymptotic notation we will also discuss in the later classes. Tell me
Okay.
if you want to say anything. There are many means there are other ways of analyzing an algorithm. We will consider the best case, worst case, and average case. All those things means for an algorithm for a particular set of inputs, which will be the best case scenario. What is your worst case scenario? Okay,
Mm.
means where the algorithm need to put the most of its effort. That is worst case. Okay, the what is the best case? Best case means the solution is almost there, means already readily available, and
Okay.
every other cases are called average case. So in
Okay.
that angle also we can analyze an algorithm.
Analyze the algorithm.
But here our aim is to give you an acquaintance of identifying what is Vigo of n
Fine.
square, because in the next classes means the regular classes you will find lots of Vigo notations and maybe some theta notations too. The
Mm. Which would
faculties
have been become very tough without knowing this.
faculties will often say you that we are considering this algorithm maybe the backtracking or the divide and conquer algorithm with the complexity of big O of n
And she has
square.
named all this.
Aha,
She has named all these methods in that
maybe they will say that since
backtracking.
the brute force is giving you big O of n square time, but we are getting a more comfortable time with
Mm.
dynamic programming, say big O of log n. So why should I not consider big O of log n? Now, if this type of statements are appeared in the regular class, obviously that will go over your head if you do not understand what is big O of n square. Why the faculty is saying that big O of log n time we will take the dynamic programming concept of big O of log n than big O of n square. Now, if you go with this class, if you understand my language in this class I used, okay, you can get all those statements readily. Okay.
Yes, correct.
Okay, the subject is very interesting. In fact, it is very interesting to me analyzing an algorithm. Okay, so
Even like something which is like math class in school actually.
okay, fine, thank you. So let's
Something
see
like that.
what we can do next class. Okay, so today up to this we have to close today. Okay, okay,
Fine.
Shashi ji, good night. Mm, good night
Okay,
to
good
the
night. Your
listeners.
meeting is starting.
Okay,
You have a meeting today?
yeah, yeah. No, actually, I do not have meeting. I have to attend, go and attend to my father.
Okay,